Hello, I'm Mrs. Mughda Bapat from SPM English Medium School Parshuram, Taluka Chikkur, District Ratnagiri. My registration number is MTE096 and the topic I'm going to present is graph and the subtopic is frequency polygon.
EKG picture. Today I want to show you EKG strips and give you a basic overview of each one. Thank you. Normal sinus rhythm. The heart rate is between 60 and 100. The PR interval measures normal. The QRS is usually narrow. The R to Rs and the P to Ps all measure regular. So normal sinus rhythm or regular sinus rhythm is this picture. When the heart rate is below 150, but yet above 100, it is sinus tachycardia. It's a faster rhythm, QRSs are narrow, but it's difficult to differentiate between the Ps and the Ts. But it usually is a regular rhythm, sinus tachycardia. Sinus bradycardia. Notice the heart rate is below 60. Patient may be symptomatic. However, it is a regular rhythm. The PR interval measures normal. It's just the heart rate is slow. Sinus bradycardia.
So let's go through the 10 high-yield EKGs I recommend you know and use the method I just showed you to analyze them. So if you were shown this EKG, you should start with step 1, which is look for the P waves. And this EKG has easily identifiable P waves that I'm underlining here, and you can see them in multiple different leads. The P waves are upright in lead 2, 3, and AVF, so that means they are normal sinus P waves. And the QRS intervals are regular, so there is no change as we go from one QRS to the next. They're occurring at regular intervals. So we have a regular rhythm with upright P waves in 2, 3, and F, so this is going to be a sinus rhythm. Now let's follow the other steps that I told you to follow. If we look at the QRS, it's narrow, it's less than 3 small boxes, so we don't have a bundle branch block. The PR interval starts right on the dark line here, and it ends before the next dark line, so it's smaller than one big box. So we have a normal PR interval, and then if we look at the QT interval, it starts right here, ends right here, and that is less than half the distance to the RRs. So this would be a normal QT interval, smaller than half the RR interval. And then finally, we look at the ST segments, and there is no significant ST depression or ST elevation anywhere on this EKG. You might think there's a little bit here, but this is really teeny and something we would call a normal variant. There's no striking or dramatic ST depression or ST elevation here. Okay, so let's move on to the next EKG, which is right here. So is wide, you just look at V1 to figure out what type of bundle branch block you have. And V1 is mostly upright, you can see that right here. So therefore we have sinus rhythm with a right bundle branch block, and that's what this EKG.
How do we do that? If I tell you to draw the normal waveforms of the ECG, how do we draw that? We have got the P wave, we have got the QRS complex, and we have got the T wave. Let us enumerate the points on these waves. What do each of them denote? The P wave is suggestive of the atrial contraction. The P wave is suggestive of the atrial contraction. That is the P wave. The first negative deflection is the Q wave, the R and the S complex. The QRS complex denotes the ventricular systole. The QRS denotes the ventricular systole will be there, followed by the PR interval. The PR interval is going to tell. So I want you to focus your attention on this inverted P wave. So if you get inverted P wave in the lead AVR, what you can confirm? You can say that the lead placement is normal. So inverted P wave in AVR is suggestive that the lead patient look for dextrocardia. If there is no dextrocardia, you will send the patient back saying that the lead placement
define and prove. You have studied different types of graphs like joint bar graph, percentage bar graph, pie diagram, histogram, and so on. Now we will go just one step ahead of it and we will see how to draw the frequency polygon. There are two methods for drawing frequency polygon. One is using histogram and the other without using histogram. Let us first recall the steps to draw histogram. Collecting the data, deciding class intervals, preparing frequency table, drawing a histogram. Now let us discuss one example. Draw a frequency polygon using histogram for this given data. The data given here is regarding the number of persons in a particular age group. The age groups are 0 to 6, 6 to 12, 12 and 18 and so on 36 to 42, and the number of persons in belonging to each age group are 0 to 6 there are 6 persons, 6 to 12 there are 11 persons and so on, and 36 to 42 there are 12 persons belonging to this group. Now let us draw the histogram. For that, let us first choose the suitable scale on y-axis. Now here we have to show the age up to 35 years, and so 2 cm is equal to 5 persons, that is 1 cm is equal to 2.5 will be the suitable scale on y-axis, and we will show the class limits on x-axis. So here the basic structure is ready. Class intervals are shown on x-axis and the frequencies are shown on y-axis. According to the number of persons, I will draw the rectangles of that particular height. For example, for the age group 0 to 6, there are 6 persons and hence I will draw the rectangle of height 6. And so on. For the last interval, I will draw the rectangle of height 12 here. So our histogram is ready. Now just one step ahead we have to go and we have to just mark the midpoints of each rectangle. Here you can clearly see I have highlighted the midpoints of each rectangle. In the same way, all the midpoints are to be highlighted, and next to that we have to just join these points with the help of straight lines. Then we will complete the frequency polygon by joining the midpoint of the first interval to rectangle, that is the rectangle, to the midpoint of the previous interval with 0 frequency and the midpoint of the last interval to the midpoint of the very next interval with frequency 0. So here the frequency polygon will be ready for you. Here you can see the first class midpoint is being joined to the previous class midpoint with 0 frequency, and the last class midpoint is joined to the next class midpoint with 0 frequency. Let us study now one more example. Here the class intervals are 32 to 34, 35 to 37, 38 to 40 and so on. If you observe it carefully, you will find that the upper limit of the first class and the lower limit of the second class are not same. Here the upper limit of the first class is 34 and the lower limit of the second class is 35. So this data is not continued, the intervals are not continued. The first step that we have to do is we have to continue these intervals. For that, we will use the formula lower limit of second class minus the upper limit of first class divided by 2. So here h will be equal to 34 minus 32 divided by 2, that is 1, and the value of h upon 2 will be 0.5. This value we will subtract from the lower limit of the first interval, and then we will go on adding this value to each upper limit of each interval. Then one more thing we have to do is we have to find the class marks. The class mark is upper limit plus lower limit divided by 2. So here now the new intervals would be 31.5 to 34.5 and so on, and hence the class mark for this first class will be 33. So the new frequency distribution table will look like this now. The intervals would be 31.5 to 34.5, 34.5 to 37.5 and so on. So you can now see the class intervals are continued. Class marks also have calculated and the related frequencies are also written. So now we will be drawing the points, that is we will be plotting the points 33, 13, that is the x coordinate is 33 and y coordinate will be 13, x coordinate 36, y coordinate 10 and so on. So the frequency polygon will be ready in this way. Now you can see here a different type of sign is used in the beginning, which is known as the crink. Now for what purpose does this sign is used? This indicates that we haven't begin with 0, that is some more intervals between 0 and 30 are skipped here, which are not shown here as the data was not lying in between those class intervals. Here is the frequency polygon ready for you without using the histogram. Let us study one more example. Here age groups are 0 to 4, 4 to 8 and so on, and number of persons again belonging to that particular age group are given. So the frequency here, the intervals are already continued. So I have just calculated the class marks and the related frequencies are given. I will plot the points 2, 1, 6, 3 and so on. And the frequency polygon will be ready in this way. Let us see now where do we use this type of graphs in our daily life. See, for the runs scored by team A and team B on first 60 balls in a cricket match are given in the table below. Represent the data of both the teams on the same graph by frequency polygon. These type of questions we can solve using frequency polygon. Then we can draw temperature time graph using this. We can even draw pressure volume graph using this type of graph. Even velocity time graph can be drawn. Here are some different uses of frequency polygon. You can see here stock volume and external activities are shown using frequency polygon. New Zealand dollar exchange rate and trade weight index is shown here using frequency polygon. Here the comparison is done using the frequency polygon. This graph shows the relative frequencies of serum cholesterol levels for men ages 25 to 34 and ages 55 to 64. So in medical field also we make use of this frequency polygon. Distance and elevation, that graph is shown over here. Birth weights, here three different quantities are compared. Density, neutron, sonic. Again serum cholesterol and relative frequencies are given. Even for different type of surveys, marketing surveys, it can be used.